Okay.
Swati,
So
can you
which
ask
one
that?
is better? If you are given a side and a diagonal to construct a rhombus, should you start with the side or should you start with the diagonal and why?
Could you please ask your question again? I didn't.
Vasant, louder, please.
I didn't get your question. Please repeat that.
See, in this case, we have to construct a rhombus. And we are given the side of the rhombus and one diagonal. So should we start with the diagonal or with the side? And
With
why?
So mostly with the side only we are drawing. So only it's look like oriented, like we always see the figure, right? So here when we flip that only we get actual figure we are seeing.
So your vote is for to start with side.
Yes.
Okay, and your reason is that way, I mean, which orientation is good? How do you describe a suitable orientation for a rhombus? See, for a square, we want the sides to be horizontal, vertical, usual. That helps us easily identify a square. Now, for a rhombus, what is a good orientation that will help us quickly identify it as a rhombus?
So the one side will be on the horizontal line.
Is that really so? Okay, so here is one rhombus that you see. This is, okay, and here is another rhombus, right? This one. Now, between the two rhombus, which one is easier? Okay, or maybe I should give you another rhombus. Hang on. Okay, yeah. So here is one rhombus, okay, or even better, here is one rhombus and here is the other rhombus. Which one helps you see that all the sides are equal?
The first one.
Okay. Everybody agrees with Vasant or is there any different opinion? I mean, it's okay to have a different opinion. Now, whoever did this, can you please mention why you chose to start with the diagonal? This is important.
I think this is from you, right, Bhavani?
This is from?
Sri Bhavani.
No, no.
Okay.
This is not mine. I did not make this.
Okay, whoever is it, come on, take credit and tell us why you started with the diagonal. It's perfectly okay to, say. Okay, I don't know why you are shying away, but anyway. Now let me point out. Yes, sir.
Swati, this is from Praveen. He just joined the call. Can you repeat the question?
Oh, yes. So Praveen, why did you decide to start with the diagonal and not the side when you did this construction?
Um, no, yeah, I think I just started. Like, I referred in some internet.
Ah, so you don't know why you started. Okay. Now, here is somebody who did it in a different way by starting with the side. Okay. So see, this person has first started with the side, then has used two arcs or two circles, one with the radius equal to the side, that is on the right, and another circle or arc with the radius as the diagonal. Okay. So this is another method.
Okay.
Now that you see this method and your own, which one do you think is better?
The previous one.
Why?
Yeah, much clear, and we can easily start from where we can easily see where we can start.
No, but what you did is perfectly fine too.
Hmm.
Okay. See, if you start with a side, okay, you have to draw these two arcs, right? And how many different radii do you need?
Only one, right?
One. The diagonal is different,
Two.
right?
Yeah, two we need.
So two radii, right?
Yeah.
And then in the next step, you use them again. So you do have to change the gap in the compass if you start with a side. Whereas the way Praveen did it, do you think he needed to change the radii at all?
No. One time is needed.
Okay. Okay. So considering this, which one is better?
Previous one is better.
Or you still want to go with the previous, even
Yeah.
though you have to use two different radii?
Yeah, we can use either one. Both the
Okay,
things are
second
comfort.
thing.
Yeah.
See, in this case, what is happening is you are first using the scale to draw a line, step one. Then you have drawing two arcs, okay? So step 2 and 3. Then you are again using the scale to draw two line segments, 4 and 5. Then you are again drawing two arcs, 6 and 7, step 6 and 7. Again, you are drawing two lines, which gets you steps 8 and 9. So total 9 steps here, right?
Yeah.
And so many times you have to switch from compass to scale. Did you notice
Yes.
that?
Yeah.
Now let us look at what Praveen did. Okay. One scale, compass. Okay. Step 2 and 3. And then scale again and steps 3, 4, 5, 6, 7. So in this second one, okay, you do not have to change radius in the compass. You have to switch from scale to compass only twice. It's scale, compass, scale. Okay. And you are done in 7 steps. Comparatively, here, You have to do scale, compass, compass, scale, again compass, compass, scale. So 5 changes compared to 3, right? And also there is a radius change, and it has 9 steps. So from this point, which one is more efficient?
Yeah, I think this one is efficient.
Exactly. Now, in order to do the second, you need to have a better understanding of rhombus, that the diagonals are lines of symmetry. So, and if the lines of symmetry are horizontal, vertical, then it is very easy to see that the 4 sides are equal, because you can mentally kind of reflect these two. If you think of this as your line of symmetry, okay, let me take a better color. Okay, if you think of this as your line of symmetry, then you can see that these two are equal. You can kind of mentally reflect and cross check, and you can see that these two are equal. And if you think of another line of symmetry, which is like this, oops, which is like this, then you notice that these two are equal and these two are equal. Okay, so that is why this orientation, or the orientation could have been like this also. Okay, where the shorter diagonal is horizontal. These orientations are better for a rhombus rather than what we had here in the previous drawing. In this kind of a thing, it's not so easy to see if the sides are equal, but it is easier to see it here, okay, because of the symmetrical alignment. I mean, these are small things, but you know, math is not all about algorithms and rules. When you build these intuitive ideas, they will help in the long run, especially when you have to do designing and the way you guys program and play with stuff. Okay, these intuitive sense will help you speed through, see things much faster. Okay. Okay, let me clear. Okay, now one more thing, very important thing. Is the name of this rhombus ABCD?
CADB,
It can CA,
DB, or
yes, it can be CADB, or it can be ACBD or ADBC.
ABC. Okay.
Okay,
Yeah.
so be very careful about the name. And that's why if you take a look at NCERT textbook, you will see that they talk about making a rough sketch. So if you are making a rough sketch, you will probably do something like this. And then you can kind of label it, okay, A, B, C, and D. And then you realize that, okay, the first diagonal which you need to draw should be labeled AC, not AB. Okay, so making this rough sketch is a very good idea. Okay. Okay, now, okay, so same thing here. It's perfectly done except mentioning that you are halving the second diagonal. Okay, I think it's important that you mention it. Notice that here Praveen has corrected himself in terms of the diagonal, naming the diagonal, which is a good thing. Okay. Okay. Now let us quickly go through the other homework. So here again is the rectangle with two sides. So that's a very standard construction. Then we'll do that later. Rhombus. What do we need? Okay, so here the steps are given, but the criteria to draw the rhombus, what is given, that has not been mentioned. Okay, and that needs to be mentioned. Okay, now from the construction, one can make out that this is again where two diagonals have been given. Okay, it seems like AB is one diagonal, then another diagonal you get, that's your rhombus. But that criteria should have been mentioned upfront here, what is given, and that is missing.
Okay.
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 Yeah. Okay, so this is rhombus with an angle given, angle and side. Now you don't need to painstakingly put all these points in GeoGebra, okay? We understand.
Okay.
So again, straightforward construction. This one again, you'll see that, yeah. So this is similar to the first one. And we have discussed why that is not the most efficient one. Okay. Then, yeah. Okay, now this one is again diagonal and side, and again similar. The comment I have regarding this is, it looks like it has been, you know, can you tell me what is wrong with this picture? Anybody? It's not, construction wise it is fine, but the way the picture has been inserted, something is not good, and it's a simple thing, small thing, but what has happened here? Anybody?
And the sides are not equal.
Exactly. That's because this picture, when after it got inserted, the aspect ratio has changed. Okay. Now, you ideally, not ideally, whenever you are inserting pictures of construction or anything mathematical, please maintain the aspect ratio. Otherwise, the lengths of sides won't be the same as you intend them to be, and a square will become a rectangle and a rhombus will become a parallelogram, etc. And that is not a good idea at all. And whoever did this realized, okay, and in the next step, look, it has been corrected. So in general, take it very seriously, that whenever you insert a picture, maintain the aspect ratio. Do not change that. Okay. So yeah, so this is again the more efficient way. And again, it is not mentioned. Again, I can see there is a crunching of the height. Okay. So why 4 semi, it's not mentioned, and as usual should have been mentioned. Side and angle. So yeah, I'm glad to see something like 70 degree, not a 60 and 45. Okay, so that's there. The last one side, one angle, 60. Okay, very neatly done. Again, very neatly done. Yeah, very neatly done. Okay. Okay. So now let us go into the comparisons. Okay. Comparing two quadrilaterals. When you are comparing a parallelogram and a rhombus, yes, opposite sides are parallel. Now, if you say, okay, now this needs to be, you need to be very clear on this. Is a rhombus a parallelogram?
Yes.
In that case, it is quite possible that a parallelogram may have all four sides to be equal. Okay. So what you need to say here, see, for rhombus, it's fine. All sides are of equal length. In case of parallelogram, you cannot say only opposite sides are of equal length. Just remove the only and you are good. Okay. And if you look at the both, then you should notice that that will be identical to what you have written for parallelogram. Okay. It's easier to check if side lengths are equal rather than see that they're parallel or not. So I'm not saying that is wrong, but you know, when you're checking it, it's a good idea to keep things simple as possible. So in case of both, you will notice that that will be identical to what the parallelogram thing is. Okay. Angle wise, I think again, angle wise, I think it will be the same across the board. Okay, that opposite angles are equal, and that will hold for both the parallelogram and the rhombus. Yes, of course, if you think about if one angle is right angle, then it will happen. But when you are comparing parallelogram, any two quadrilaterals, you don't want to get into their special cases. Okay. Now, for a parallelogram can have diagonals of equal length. So can a rhombus. So it is not a good idea to say that they are of unequal length. They can be of unequal length or they can be equal. So when both are possible, it is better not to mention anything regarding the length. Okay. Now, for rhombus, diagonals are perpendicular to each other. That is correct. And of course, they will be at point of intersection. So see, math people are lazy people. Okay. We say only what is needed and we leave out all the fluff. So if the diagonals are perpendicular, they have to be at the, at the point of intersection, nowhere else. So it doesn't need to be mentioned. Okay. There's nothing wrong in saying that, but we are lazy people. And this is where math becomes very concise. Okay. That we, leave out the fluff. So yeah. Now again, for parallelogram, you cannot say diagonals are not perpendicular. Okay, they can be. So what you need to say for parallelogram is that diagonals bisect each other, which is also true for rhombus. So for parallelogram, it will be diagonals bisect each other, rhombus bisect each other at right angle, or diagonals are perpendicular bisectors of each other. And when you draw out the common thing that applies to both, you will notice that whatever applies to parallelogram, that holds for both. And from there, you kind of get a sense that, okay, so rhombus, all the rhombi are basically special parallelograms. Okay. So, yeah, we'll come to that later. So let's now look at, okay, so this is rhombus and square. Let me just check if there are any more. Okay, there is no more here. Okay, here. This is rectangle and rhombus. Okay. I'm just trying to see if there are any more parallelogram and rhombus here. Parallelogram and rhombus. Okay. All sides are of equal length. Opposite sides are equal in length. So again, when you look at both, it's not at least two sides are equal. It is same as what is there for parallelogram. Both pair of opposite sides are equal. Okay. Yeah. So if you at the angle, it's pretty much the same statement throughout. Now, when you're talking about diagonals, I don't know. Okay, I think that's a copy paste thing. You forgot to change that. Diagonals bisect each other, diagonal are perpendicular bisector of each other. Yeah, so that's good. Yeah. Okay, so that this we are done with. Kite and rhombus, square and rhombus. Okay, so now let's go to square and rhombus. Sides are parallel. Again, yes, they are both parallel, okay, in this case, but you did not bring out the difference, or I mean, the more important thing is that all sides are equal. See, when you say opposite sides of rhombus are parallel to each other, same goes for rectangle, same goes for parallelograms. But that doesn't bring out the specialty of rhombus or of squares. So that equality is more important here. Okay. Angle part is good. Okay. Okay. Again, rhombus, the parallelogram, whose diagonals perpendicular are perpendicular bisectors of each other. Okay. You cannot say the diagonals of rhombus are unequal in size. It can also be equal because square is a special rhombus. Okay. So that last line should be removed. Now, in the square part, you mentioned they are perpendicular, you mentioned they are equal, but you did not mention that they bisect each other, and that should have been mentioned. Okay. Okay, now this is again another square and rhombus. Four sides are congruent. Okay. Now, when you are comparing square and rhombus, and you see, when you are talking about consecutive sides are perpendicular or not, you are actually commenting about the angle. So why not leave that for the angles row? Okay. Are congruent and all, okay, this is perfect. All angles are congruent, opposite angles are congruent. And we had already talked about it. Opposite angles are congruent and consecutive angles are supplementary. They're equivalent statements. So it's better to, you know, have the same thing. What do you mean by bisect vertices? It should be bisects the angles, not vertices. How do you bisect a point? A vertex is a point. Okay. Again, you cannot say diagonals are not congruent, but that the diagonals are perpendicular hasn't been mentioned, and bisect should have come under both. Okay, I think the last one is kite and rhombus. Okay, glad to see somebody did kite and rhombus. Is this true? Any Any two sides are equal in a kite.
Pair of two sides are equal.
Adjacent sides. Two pair of adjacent sides are equal.
Okay.
So be careful on the language you use. Okay. There are two pairs of equal adjacent sides for a kite. Rhombus is perfect. Okay. And the both again will be like the kite. Okay. If you think about it. Two pairs of opposite angles are equal, one pair, and it's good that you have put at least there. Okay. Now, in case of kite also, you should have mentioned at least, because the other can be. Need not always be, but can be. At least one diagonal is perpendicular bisector. Again, yes, at least. Yeah, this is good. Okay. Okay. So, and we have rectangles and rhombuses. Rectangle rhombuses are more interesting. Any guess why? Why rectangles and rhombuses are more interesting? See, let me see if there is a white space. No, that's okay. See, when you have, let me just do. Whiteboard. Okay. So, the first one was parallelogram and rhombus. Okay. Now, in this case, all rhombi are parallelograms. Okay. Now, second, then we talked about squares and rhombus. Square and rhombus. Now, there also all squares are rhombi. Okay. Third was kite and rhombus. Now again, all rhombi are kites. Okay. So in each of this situation, you see a set subset kind of a situation. Okay. So let me just draw to illustrate that. So this is parallelogram, and then let me just draw all three maybe. So here it is rhombus, and here it is kite. Okay. Now, we have these cases. Okay. Now, this is rhombus. This is square and This is again rhombus. Okay. So this is the relation. Okay. There is a very clear set subset relation. Okay. Now, can you annotate and show how rectangle and rhombus are related? So can one of you do that? Draw a similar picture for okay. Can one of you annotate and draw it? Come on. I'm asking you to scribble on the screen. Okay, good. Okay. Are you sure that is the case? Is it like one nested completely inside the other? Yeah, that parallelogram outside the rhombus is good. But as far as rectangle and rhombus are concerned, are they, is it all are all rhombus rectangles?
No.
See, if we consider this picture, then it appears that all rhombi are rectangle. Is that true?
No.
No.
Okay, so that's not the case. Okay, so I'm going to erase that one. Okay, now what is this? What is this one?
Square.
Okay, but we asked for rhombus, so that's fine, that this can be a square. Okay, so let's move this. Okay, and let's say this is a square. So where is rhombus? Okay, so the red one is rhombus.
Yes. Is it
But
correct?
if the, oh, okay, now, okay. So can the red one be rhombus?
No.
Okay, so let's remove the red one. Now somebody had drawn a, not a circle or an ellipse, but something else. So you can draw that again. I mean, it doesn't have to be a perfect ellipse. A squiggly closed shape is perfectly fine. Yeah. Yes. Okay. Now, do we really need that little oval called square?
Or maybe intersection.
Yes, exactly. So we don't need this one. Okay. In general, if you have two sets, okay, there are these possibilities. It is possible that they don't intersect and they are like this. Okay. It is possible. Okay, let me change color so that I will, okay, let me draw all three and then I'll change color. All four. Okay, so this is, now let me, okay. So this is one situation where they are completely disjoint. This is the situation where one is inside the other, and this is where, you know, it's the other way around. Okay. And this is the third situation where they intersect. Now, in case of parallelogram and rhombus, we or the previous three cases that we considered, it's the middle two that that kind of that was the case, right? One of the other. In these two cases, the rhombus was the subset, and in this case, the rhombus was the superset. Okay, so yeah, so that happened. But rectangle and rhombus, they are not like these two. Okay, I mean, think about it. In a rectangle, the diagonals are equal, but they may not be perpendicular. In a rhombus, the diagonals are perpendicular. They may not be equal. Okay, so obviously these cases are not possible. Neither is a subset or the other. Okay, but they intersect in the sense that, can we have a quadrilateral whose diagonals are perpendicular and equal, and of course bisect each other? Yes. Okay, and that is why this last one works. Okay, see, the first task which I had given you was now I've forgotten which one I gave you. Was it a kite and a parallelogram? Original task? So
The very first one was
Yeah.
kite and parallelogram.
Yeah, so kite, the reason I gave it to you is because kite and parallelogram also have this kind of a relation. Those are the fun ones. Okay. So here are certain explorations you can do. You know, there are different types of quadrilaterals, and you pick randomly any two and you see which one, you know, is applicable. This one, this one, this one, or this one. Okay, for any two pairs. And if you do these kind of exercises, then it helps you, you know, strengthen your understanding of the quadrilaterals. Okay, see, triangle is the simplest polygon. Okay, 3 sides, that's the minimum you need, no diagonal. Okay, so that's a simpler thing. But the moment you bring in 4, the complexity increases and more fun begins. And quadrilaterals offer a lot of fun. Okay, so that is there. Yeah, so that's why rectangle and rhombus are more interesting. Now I will stop share and go back to the previous one from where we started this. Yeah, okay. So rectangles and rhombuses, two pairs of opposite sides, you should say. Or again, I think when you are writing both, at least should be mentioned. Maybe. Okay, again, adjacent sides perpendicular is a comment about angles. So that should come down to the next one. Okay. Rather, when you're
Okay.
talking about sides, you should bring out the differences maybe. All four are equal. Here, opposite pairs are equal. Okay.
Okay.
Okay, angle opposite angles are equal is great. Again, like for rectangles, it will be all four angles are equal, and for rhombuses, opposite angles are equal. Now, in a triangle, the equilateral meaning equal sides. Okay, triangle with all sides equal. That also happens to be the equiangular triangle, meaning all the angles are also equal. But the moment you get to quadrilateral, they become two different things. Now, if you think of rhombus, that's the equilateral quadrilateral. Okay. And if you think of rectangle, that is the equiangular quadrilateral. Now, I don't think most textbooks talk about or define rectangle this way, but equiangular quadrilateral can be a perfectly fine definition of a rectangle. Okay, it's simple and you can derive all the properties from that, which of course you can take as a homework. Okay. Rhombus as the equilateral one is the more popular notion, but people usually don't think of rectangle as the equiangular one. Okay. And that comes out very nicely when you do this table. Both diagonals are inside, and yeah, so yes, they do intersect each other. You can write it in short with both diagonals bisect each other. Okay.
Okay.
Yeah, and you can see that, see, diagonals are of the same length for rectangles. In rhombus, they are not necessarily. Thank you for writing not necessarily, but they are perpendicular. Okay.
Okay.
That you should have mentioned.
Okay.
Okay. Now, what I would like you to do is, now that we have discussed these things, it will be a good idea to for you to, each of you, to kind of consolidate and update your homework, whatever you have done. You don't need to share it again with me, but if you do that, then the updated version will be there with you. Okay, so if you can do that, I think that will be a good idea. Okay, now this one, we just have 1 minute left, so I'm not going to get into this one today. We are going to discuss it tomorrow, in the next week. And there are things, think about these things, okay? When you are talking about rotational symmetry and you put a 4, that means the order of rotational symmetry, okay? Now, the minimum order has to be 2. If the order is 1, that doesn't really have a rotational symmetry. That means you have to make it go around full 360 degree to, make it come back to its, for it to be invariant. So this one here doesn't really make too much sense. Okay. You may want to add the order here in bracket. Also check if all of them have rotational, like square, of course, it's the regular quadrilateral. So it has four-fold rotational symmetry or rotational symmetry of order 4. But check if it is the same for rhombus. Okay. Yeah. And then
So is this considered proof, Swati?
no,
Yeah.
we need to discuss this next time. Okay, but I just want to get started. Now, when it comes to line of symmetry, this is perfectly fine. Okay, no problem that way. Okay, kite, rhombus, square, all of them have line of symmetry. Okay, now there is something here which is isosceles trapezium a special rectangle? Does this is an isosceles trapezium. Does this look like a rectangle to you?
No, it's other way.
So fix it. Okay. Fix it, and then this is something we are going to discuss next time. Okay.
See, the idea
So-
of giving feedback, Vasant, is that you incorporate it and you send it out again before you send it to Swati. We've already discussed this.
Yes, thank you.
All right.
Okay. Okay. So I'll stop share. So what will you do for homework for this week, for the upcoming week?
Swati, if you can send one proof, I think you did one proof last time, right? Can we
Yes.
also think about how rigorous are proofs and what does it mean, right? You start from something and get to something.
Okay.
I mean,
Okay,
at least
so
what
that-
is it that I'm trying to prove and what do I know? There are two different things.
Yes. Yes. So last time we discussed that quite thoroughly.
Okay.
Okay. So maybe we can give you homework along those lines. So let me, okay. So, okay. And these are kind of, so these are you. Okay, so this is 1 and then I'll give you 2. Okay. If anybody wants to do more than 1, please feel free to do so. Now, the last one, you should find it a bit amusing because see, both kite and isosceles trapezium, they have line of symmetry, okay, that you have figured out already. But neither has rotational symmetry, okay? Now, the quadrilateral, which is both a kite and an isosceles trapezium, see if it has rotational symmetry. And I want you to think why. None of the original ones did. And then suddenly, why did, this one, if it doesn't have, fine, right? It was not there, so it was not there. But if it crops up, why do you think it cropped up, from where, out of the blue? Think about that. So this is your homework. Okay, so 2 questions and you have a choice. Okay, so in case of both, right, whether it is an isosceles trapezium or a kite or a rectangle or a rhombus, in each case, you have to very clearly state, what do you mean by an isosceles trapezium? What do you mean by a kite? So this first definition of a rectangle is your starting point. This is what you have, okay? And the second one, the isosceles trapezium or kite, that is what you need to achieve, okay? That's where you need to go, okay? So this part is given. This is given, okay? These are the given parts, okay? Okay, and these are to be proved. Oops. Okay. This is pathetic handwriting with the mouse. I mean, with my finger as the mouse. Okay. So, starting point and where you need to end up. And the proof is the journey, so to say, the steps. Notice that in the second question, you still don't know what exactly you need to prove. You have to identify and then establish that identity. Okay, so that's a different kind of exercise. Okay, that's all for this week. Any question, anything?
Thank you, Swati.
Okay.
Thank you, Swati.
Bye.
Thank you.
Thank you.